Yeah, hi. Uh, this is Prabhakar from Box Heroes. So this is one of my other videos that I want to make about how JavaScript works in React. Sorry, JavaScript works in browsers, and how React also leverages the underlying architecture of how JavaScript works. So, so when I say what JavaScript works, how JavaScript works, so I would actually mainly uh, talk about the event loop, the call stack, basically the JSEngine, right, and the callback queue. So how all this come together, and also I would also talk about the browser architecture in general. So I would not go deep around this, but it would help to grasp the relevance around this. So okay, so let's start with this one. But before starting, I would quickly talk about myself. So I'm Prabhakar, and I am a software engineer. I have more than 10 years of experience in the software industry in different companies, from startups to large multinationals. And I have been exposed to as a full stack engineer, and also different development platforms, from starting from Java, JavaScript, React, Angular, Node, Python. So I've also worked on IoT using ML models, AWS, microservices, etc. So it's a large, big bunch of technologies that I've been exposed to, and I'm very interested in this area. So today I thought that let's talk about JavaScript event loop, etc., which I have been quite interested to know myself, and I had explored it myself. So I think it would help to empathize how React works, how JavaScript works. So it would be pretty interesting going forward. So maybe I will not be able to cover the whole parts here in at one go, including the React leveraging the JS working fundamentals. But I would try to cover the JavaScript part, how basically it works with the event loop. So so this one I saw in the JavaScript daily. So uh, actually this was posted in one of our group channels and our group places by a friend of mine, and I found this pretty interesting actually. This is taken as a joke, because you are not doing actually in reality any sorting here. You are just doing a set timeout on the number, and since the timeout number is larger, so it would come out last, so it would get printed last. So whichever timeout is smaller, so that it would get printed earlier, and so it would get sorted, right? So it's a comedy, calling it a slip sort. But something very interesting is here that you might want to see. So if I want to ask a question around here, like what is the time it would take to run this whole thing, right? So obviously this is not very efficient, right? So because the larger the numbers you do, the larger the time it has to wait, right? Set timer. So it is not a very efficient way of sorting, but it does the sorting, but it's absolutely randomly, performance is totally it depends on the number size, the max number size, right? The smaller the numbers, it will be faster. That's it. So but the question, coming to a question like how much time it would take to sort this. So you can think about this one, and you can answer it yourself later. I don't think it's too hard to answer this one, but it's very interesting, and you will find the relevance why I talked about this one. Okay, so basically JavaScript is mostly known as a single threaded. So single threaded means it's true, it has a main thread, it's a main godlike thread that and it does everything. Most of the main synchronization is done by this thread, all the handling. So basically whatever actual works that transpires finally, that you can see, that you can get around with in the browser, that you see, it's finally because of this main thread. But it's not it will be false to say that it's the only thread that runs there in the browser. So there are other threads, they are like worker threads. They lie in wait for any asynchronous work. So there's something called web APIs. So these are something that is separate from your core JSEngine. So it works out there. So that actually does the asynchronous operations. Hence, those are that's where the worker threads come into play. Different threads. So the whole asynchronous operations are covered by these concepts. So you have a callback queue. Okay, the callback queue is nothing but different kind of tasks that get pushed, get line wait to come back into your call stack. So your call stack is the place where the JS godlike thread, main thread picks tasks and performs them. Okay, like calling a function, adding a number, everything happens here. So, and the event loop is the one that actually picks whatever callback tasks come back from your external operation, asynchronous operations that are done outside your JSEngine. They come back, so they need to get picked up back into the call stack. So this sounds a bit complex here, but it will get clearer in a while. So just keep in mind that these are the main three building blocks. Okay, so tasks, micro, macro, render, these are different kind of tasks. So micro task and macro task, so these have different priorities. Okay, so browser observers promises have higher priority, which comes via the micro task queue. Then you have the macro task queue, which is lower priority DOM events like timer events, set timeout events, like something of that sort. So so the main thread also runs the event loop here, if you see. So if the main thread is busy with a call stack, nothing can be picked from the tasks by the event loop. So it is blocked in. So until the call stack is free, the event loop cannot work. So nothing can be picked from the task. Okay, I'll come back to that one. So these are the main browser functions. So you must remember there's a fetch part. So these are the four main functions of a browser: fetch, process, display, storage. The fetch is the network part, basically the processing to get the content from the network, that interaction, fetch part. Process is the rendering engine, JSEngine, UI backend systems. Okay, backend systems that interact with the operating system, and JSEngine that takes care of JavaScript interactions, and then your render engine takes care of your display processing. Okay, and then you have the display, that is your browser engine, the UI interface, right? The browser engine is the basically the bridge between your UI, browser UI, and your render engine. Okay, so it basically marshals the interactions between them. Okay, so then you have the storage, your local storage, cookies, session storage, etc. It's come on the storage. So these are the four main functionalities that are covered by the browser, and that's how browsers work. So JSEngine is a subsystem for parsing JavaScript code to machine code and executing it, right? So these JSEngines actually they conform to a specification. Okay, like ECMAScript or WebAssembly. They support these kind of different what you call specifications, by which that's why these engines support JavaScript. So JavaScript is conforms to ECMAScript, TypeScript, JavaScript, I think CoffeeScript, etc. conform to ECMAScript. So there is something called WebAssembly as well. So this is something else. So this we can explore in a different different video. This is a whole different thing. So yes, but this is something we can say that JavaScript is conforms to an ECMAScript standard. So that's why V8 engine or any other JavaScript engine can comprehend it and use it. And it is and there's a rendering engine. The basically it's the main part of the system, your what you call your browser system, where subsystem, where it helps to comprehend how to parse and show your representation of your pages, the whole UI of your pages. Okay, not of course your browser UI, where your back button, forward button, history button, etc, etc, right? So not that part. The part that your is dynamic, that is your pages itself, that part is rendering engine. Okay, so rendering engine also comes in different forms for different browsers. So Chrome, Opera both use Blink, Firefox uses Gecko, IE uses Trident, Edge uses Edge HTML, Safari uses WebKit. So they come in different flavors, okay, different names. And the browser engine is an so that is again an interface between your what you call your UI part, user interface, browser interface, and your rendering engine. So it handles the interpretation of interpretation and interaction between these two parts, that is your user interface and your rendering engine. So it sits between them. So this is the high level architecture of a browser. Okay, so this is your persistence part that I've talked about, local storage, session storage, etc, right? And this is the JSEngine that is that we talked about. This is the networking part that takes care of your networking calls, HTTP calls, etc, everything, security, etc. So this is your UI backend. So this takes care of your interactions with your operating system level, to be able to generate to leverage on the operating system's capabilities to show some graphics, to drawing something on your browser, etc. So the boxes, etc, everything, right? Those this is supported by via this part. Okay, so this is a little more detailed one, and this is more specific to the Chrome browser architecture. Okay, this is where different parts stay. WebKit, this is the rendering engine, this is your V8 JavaScript engine, XML parser. Okay, you see different parts. So this is just to give an idea. We are not going to go deep in each part, so it's a whole different story. So this is your JSEngine, so of the V8 JSEngine. So it's particularly, you can say, similar to Java JVM, Java Virtual Machine. So you can say it is something similar to that. So you can say it helps in the interpretation to bytecode to interact with operating system finally, and also optimization of the code. Okay, so it has all these workflows to handle your JavaScript. Okay. So this is your rendering engine from Chrome, the WebKit. So basically it takes the HTML part, the DOM tree, creates the DOM tree, uses the style sheet, parse styles rules, applies the style rules, and creates this uses the layout, he creates an attachment, uses attachment, etc, everything, and creates a rendering tree and paints it to display. So this is your basically flow, how it works, just to give an idea. So now coming to the JSEngine. Okay, so it basically you have a runtime. Okay, so a runtime will have your this is your JSEngine, where you have your JavaScript objects and stack. Okay, so where you run your so if you see, you call foo first, so it's a bottom of the stack. Then when you call foo, you call bar, so it's added on top of the foo, and then baz, and then log. That is the last after calling baz, right? It came here. So you do once this is done, log is done, it goes out of a stack. Then it goes out of baz. In baz, nothing else to do. Then goes bar, goes foo, then the whole stack goes empty. It operates in this way. Okay. So if there is any storage of objects got created, so it will get stored here. So this is a much more broader picture. So this is what we showed in the earlier slide. So you have a stack that works on your different functions, takes one at a time, calls main, then shows text, and set timeout. Set timeout is done, then your show text is done, then main is done, then maybe from the callback queue the timeout call has come back, it came back into the stack, then it completes it, and then it closes, its stack is empty. So if you see, the also an event table is there, which is not shown here. So it registers and tracks status of completion of operations before pushing to callback queue. So any tasks that go out of your go asynchronously, that is out of your stack, that is like calling for a set timeout. So these web APIs handle it as X events, so network calls, right? Timing, and maybe request for some change in the UI, some asynchronous events that trigger the rendering engine, etc., everything, or something like that, right? So or some other web APIs, right, installed on your system, which are basically some C++ implementations. Okay, so these are handled parallelly by other threads. Okay, and once done, so they need to be tracked when they're complete, so that the event table says that this is complete. You report to event table, and event table says it's complete. Then you need to push it here in the callback queue, if so that event loops can pick it up when it is free and pushes it back to the call stack to be implemented. So as I have already said in one more earlier slide, there are macro task and macro task queue, and macro task queue is higher. So there are other queues as well. I think there is rendering queue as well. Okay, rendering for the rendering engine especially. So these happen. So it's a pretty different, interesting architecture. So all this while this is run by a single thread, and asynchronous events happen here. Okay, which are like IO bound events, file systems, file calls, etc., everything, right? Fetch, network events, etc., goes out of this area. So they happen mostly asynchronously, they don't happen via this JSEngine. So this is a much more broader, much more step-by-step explanation of how it is done. I think you have got the hang of it. So you have got console log A, it's called main, then you're calling set timeout. Okay, set timeout moves to the browser API, some web API. Okay, then you have console log C, so A gets printed, C gets printed. Then you have in the callback queue, finally the event loop is able to pick up because the call stack is empty now. Then it gets it, so the main thread has time to run the event loop and get this final set timeout console log B. So it is like A, C, B, it will get printed. Okay, so there are different JS engines. Okay, so there are different JS engines by Chrome, V8, Mozilla, SpiderMonkey, IE, Chakra, Safari, JavaScript code, and Facebook Harms. Okay, so and NodeJs also uses the V8. So V8 again is very much similar, so as the browser, so it's the same engine. So apart from that, you will have some worker threads, so to take some blocking operations like this database file system. So when you say blocking IO operations, basically you need to wait for them to come back. Okay, and whatever non-blocking IO operations will be stay in that stack and get implemented one by one, and whatever is like blocking, then they would go out of the call stack, taken care of by this worker threads internal thread pool, right? And they would come back, push back into callback queue, which is not shown here clearly. Then they would get event loop would push it back to the call stack, they would get implemented. So it's pretty interesting, right? So basically all the while you might have seen that there is only one single thread here, right? So you might be wondering what good does it do. So finally, does it actually help, or it just just a it could have been better using one more thread, so multi-threaded. So one thing is pretty clear here. So if it's a single thread, it's kind of pretty simple. You just need to focus on one task at a time. And since so also it is imperative that you keep the thread free. So the architecture is such that you don't do anything that blocks your in handling that stack here. So if something takes more time, please take the time out to do it somewhere else. So your main thread is always responsive. So your application, your page, where people are used to getting faster responses, and they should be getting faster responses. So it is expected that you keep your main thread non-blocked. It should not be blocked. So you just focus on one thread that is coming. You don't focus on having parallel paths around this. Okay, you just focus on one path, and you keep on doing the tasks. Nothing should stop it from doing any task. So if it's every small task that comes into its sphere of the call stack, let's do it. Okay, let's do it. And if it's something that's going to block it, takes more time, it's IO bound, it's not CPU bound, I mean, it doesn't do a for loop, etc., add some numbers, then please take it out of the call stack. Okay, so it goes out of call stack, it goes there, takes its sweet time, and comes back, and only when ready it goes back to the comes back to the call stack when the JS the main thread is free, right? So it's pretty efficient actually having one thread, if you ask me. So it's simple, and it it gives you a clear idea of like what is expected. So you keep the things moving. Okay, you keep the things moving, you keep it responsive. That's the idea. So it's a pretty simple yet very effective concept of what underlying architecture supports. So when you are actually building your frameworks over this, like Angular, React, right? So they try to leverage this, the whole idea of how JSEngine works, how JavaScript works, how the rendering engine works along with the JSEngine. So this browser architecture is pretty interesting. So I would come to React later on, and we would visit this idea of how React leverages this concept, and what did it do to take advantage of this architecture and become more responsive. Okay, so having said that, you would also learn about more about React the next time around when I talk about it, but also be able to understand from the perspective of what JavaScript is. So if you have any questions pertaining to JavaScript anytime later, then please do let me know about this, and I will try to answer them. So I hope you found my sessions interesting, and I will come back with a new one very soon. Until then, thank you everyone for watching this, and I would like you to request you to share, like, subscribe, and if you liked it, and if you haven't liked anything, please do comment. I'd like to improve it, my presentations, and if I made myself clear. And definitely would love to catch up very soon then. Thank you. Bye.